Hi, in this video I would like to show you how to set up some calculations in Excel, both with just using the spreadsheet function of Excel as well as setting up a set of macros. So we're going to implement Euler's methods. Euler's method is a way that you can integrate when you have the derivative as a function of x. So in this case we have a dy dx, that's our derivative. And the functionality that I picked for this example is 0.25 times x squared. So I'm using this cell D2 to represent the x just so that we get the value in there. You can see if I change it to 0, then my dy dx is 0. Because this is in Excel, anytime we put a function or a math calculation in there, we always have to start with a 0. We're using the asterisk to indicate multiplication, and then the shift 6 to get the up caret to indicate raised to a power of. So this would be the cell D2 raised to the power of 2, or D2 squared. To do an Euler's method integration of a derivative in this way, we need an initial y. So here's just a 0 for under initial y. And then over here we need an initial x and then a final x. So this is the integration between x is 0 and x is 2. And then we need a step. So we're going to chop this path up into steps of 0.01 in this case. So to set up just a regular old spreadsheet, you have your x column and your y column. Under your x column for your first x, you can just set it equal to your initial x, so my h2. So I just have equals h2. Under y, we'll set it up to be equal to our initial y, so just equals f2. Then our next x's need to increase, so we're going to do a5, which is the cell just right above it, plus a cell j2. Now the problem is if I copy and paste this down, then the reference will also go down, and these cells are all blank. So instead of referencing my step of 0.01, it's just going to reference a 0. So to get around that, I put a $sign in front of the J, and that means as I copy it, never move it from column J. And then I put a $sign in front of the 2, and that says as I copy it, never move it from 2. So this is an absolute reference there. And then we'll set up our y. So for our y, we have our function in here, so it's going to be 0.25 times the previous x value squared times our step. And again, our step is an absolute reference, so it needs to be $J, $2, plus our previous value of y. So what we're doing is we're using the derivative to basically linearize our function, and then we're going to take that little step and then add that to the y value, and then take another little step and add it to the y value. There's lots of resources online if you want to investigate Euler's method in more detail. But this is just an example of using a spreadsheet for some kind of numerical calculation. So then to finish it, we'll select the cell where we have our x and our y, the one with all the functionality in there. Just select that, do Control C to copy it, and come down here, and you can paste as many in as you need. I don't want to mess up my formatting, so I'm just going to do paste special with formulas, and then you can see if we're way down here, the formulas have updated correctly, but that absolute reference with the $signs in there is still in there. And so looking at this function, if you actually integrated it and you check the value of what it would really be at x is equal to 2, you get 0.667. So using this Euler's method with the step of 0.1, we get 0.662. You could take it one additional step if you wanted, which would overshoot a little bit. This will be a little bit of an undershot since we're stopping at that value. So now let's look at, well, what could we do if we're going to do a macro? So the first step with the macro is to go to File and do Save As, And make for sure that you're saving it under an Excel that has a macro enabled workbook. So it'll be the .xlsm. I've already done that, so I'm going to go back. And then you go to View, and then under View it says Macros, and then you click on Record a Macro. So I'm going to do that and give it a name and describe it. And then just whatever you want to start your macro. So I'm just going to click on that one cell, and then I'll do stop recording. And let me show you what that does. It creates this macro, so the new one that I've got is called name. And then when you edit it, it brings it up into this blank brings it up into this editor, and we can see that we've got the code in here. So here's name down here, and you can see name is blank. The only thing that it did was it just selected that one cell. This is the function that I went ahead and built in the macro after I recorded a blank macro. So let me walk you through this and also look at the spreadsheet, and then we'll see what this is doing. So this is Visual Basic. So it's a programming language called Basic, but it's Visual Basic for application. So it has these objects that are built in that reference back to your sheet. So it's not strongly typed. So when you want to create a variable, you just name the variable and then you start using it. It's not like C++ where you have to define the variable as a float or an int or anything. So I can use a variable x0, and I'm going to say equals, and then this is one of these pre-built that references my spreadsheet. So it's range, and then inside of the parentheses I have double quotes, and inside the double quotes I have the cell value. So this is going to go back to H2. H2 is my initial x, and then dot value just means read whatever the number is in that cell. So it's going to take that 0 and store it in x0. Next one's going to take the 2 from I2 and store it in xf. Then it's going to take the step from J2 and store it in step. Then it's going to take the 0 from the initial y and store it in y0. And then we need to determine how many times we're going to go through this. So this would be the final x minus the initial divided by the step, and then we'll subtract 1 so that it ends on the right at the final. And then for our y value, we'll go ahead and set it to the start. So y is equal to y0, which is our initial, or y0, which is our initial. X is equal to x0 for x0. And then for my derivative, I'm using dy dx as a variable name, and I'm just setting it equal to 0 just to initialize it. We're not actually going to use that value to calculate. This is my for loop. So this loop is going to go from a counter. I'm using I to represent that counter, and the counter is going to go from 0 up to count. So that's the one that I set here. If I wanted to run it from 1 to count, I could get rid of the -1 here, but since I'm doing 0 to count, I need that -1 to make for sure that it's got that offset. So now I'm going to pick up a value from the spreadsheet. So I'm going to go to D2, which is the value of x, and I'm going to read that into x. So that replaces that x0, and that's fine. Then I'm going to do my dy dx is equal to the range of E2. So my function that I typed in here depends on D2, so it's going to get that new value for the function and put that in my dy dx. Now here's my Euler's method calculation. My y is equal to my previous y. It doesn't change it here until it gets the whole calculation done, and then it stores it in y. Plus the derivative times the step, and we read all that stuff from the spreadsheet. Then it increments x, so it says x is equal to x plus step, and then it goes back to the loop with I being the next value until it hits count. Then when we're done with the loop, we want to store the value in Y. So we do range G2 and say that equals Y, and then that takes us and gives us the value from the calculation. So let's just stick a 0 here in our final Y, and then we'll run this macro. So we'll go to macro, view macro, we've got Euler's, and then we'll click run. And you can see it chugging through, and you can see that it got the same value that we got from the using all the rows and columns over here. And then sometimes when we set this up, it might be slightly different if we run it a second time, so it's always good just to double check and make for sure that the first run didn't affect anything. Okay, and it appears to still be okay with that. So this is a way that you can record macros, and you can use this to do numerical solutions in Excel, but you can also use this just to create functionality in Excel documents. So if we wanted to get fancy here, we could have maybe a button that has some functionality. When we click it, it runs a macro and does something. You can also use this with Excel or Word. So that, let's say you're doing a company invoicing system, you type in some information somewhere and then run the macro, and it'll auto-populate the rest of the form. So this is a really nice way to program. Visual Basic is fairly quick to learn compared like with C++. So I hope that you'll continue looking at macros. Engineers tend to program in macros a fair amount, since a lot of engineers are using Word and Excel during their daily job. But just another tool that I wanted to introduce you to, not expecting you to be an expert in macro programming, and this is really the only time that we'll use it through the course. So thanks.